So, to start off, we're going to start with Liliana Bernardino from Sonai and Sid.
Good morning to you all. There's so many of you here this morning. My name is Liliana Bernardino. I'm here to speak to you a little bit about intelligence. Not the brain intelligence, but analytical intelligence. The case study that I bring today is the case study of retail, Portuguese retail marketing, food retail marketing. And saying this, I'm going to speak to you about Sonai MC and how we are empowering our business using advanced analytics. So empowering our business, new intelligence. So moving forward, first of all, I will make to all of you a little bit of context, how we felt the need to go further in analytics, how we felt the need to go further in advanced analytics. Because the world is changing, so is retail, so is consumer, so we need to adapt to this change of the world. And after that, I will give you some examples, how we are using advanced analytics in practice. Which type of algorithms, which type of models are we using, how we are using those models, and afterwards, if you want, you can make me some questions. I hope, as it's on me to start today's session, I hope after my intervention you don't run away of the room. I hope that, and I'll be very happy if at least 95% of you will stay. So let's moving forward. First of all, how was the retail in the 20th century? It felt like it was 100 years ago, but it was not. So we are in 2017, so it was more or less 18 years ago. So in terms of retailing, what we had less competitor stores. With this, we had non-demanding customers. Customers were always loyal, always happy with everything that the retailer had in shelves. So the aim of the companies, of retail companies, was just to keep good results. And how to keep good results? Analyzing what happened. Let's look backward and see what happened in a certain campaign, in a certain store opening, and so on and so on. When things go wrong, why did it happen? These were more than enough. Okay? Just to keep good results on the late of the 20th century, this was more than enough. But then the 21st century came in. The Internet of Things, since more or less in the end of the 20th century, everything changed. People has changed, the market has changed, all of the world has changed. So, the increase of competition, more than that, more technology. With more technology, more available services. You know that before, about, 15 years ago, who would have thought that people would have an app on their mobile phone to purchase something? Maybe some visionaries here in the room, but not all of people that today have apps on their mobile phones. Lifestyle changes. I think this is the more important slide of all. Who of you remember about 20 years ago of people running in the streets about 6 o'clock in the evening? No one? And today, who of you runs at the evening? How many of you? Please raise your arms. So people are much more health conscious, right? And this is because people have access to more information. People know that if they don't run, they will be sick, or they won't live longer and they won't live younger, right? All of this technology revolution, all of this market complexity increase made people to change. More digital. Everything is digital nowadays, right? We have mobile apps, we have everything on the internet, right? Who of you today purchase something, clothing, I don't know, sports, and stuff like that on the internet, on your sofa, very comfortable on your sofa? About 20 years ago, this was impossible to think of. More emotional. All of us here in this room, I can guarantee, they are much more emotional than you were, the ones that was born before that, 20 years ago. Today, people smile, people get angry with much more easier way than they did about 20 years ago. Because now they feel that they can. Now we can be emotional. About 20 years ago, this was not more like that. So, more demanding. As we are more emotional, we know that we can demand something. And when we go to a store, when we go to a food retailer or to, I don't know, a specialized retailer, we know that we can demand for services. We know that we can complain, because if they don't do what we want as customer, I go out and I go into a different store. I will go into a competitor. All of this make all of us more intelligent customers, right? We are more intelligent. We are more emotional, we are more digital, but we are more intelligent customers. So, the loyal and follower customer in the end of the 20th century, like the little dog going and running after running after a ball that the retailer turns into him, turns into a burdensome, very, very complex customer. So the little dog turns into a cat. Do you understand the comparison? As a dog, do everything that the owner says him to do. A cat sometimes doesn't even know his name. He doesn't care. He do everything that he wants to do, right? So, with the change and this retail change, this retail paradigm shift, what it says is that we increased in customer and in competition complexity. So, how to win the game? Sorry for the non-Benfica fans. How to win the game? It's easier, right? If you go onto the internet, every single site of marketing says that it's very important to implement customer centricity policies. Okay, but what is that? And for what is that? Customer centricity policies are very important to speak customer language, to understand exactly what customer wants, and to put that in the same place on what is better for the retailer. Okay, this is very funny, right? It's very funny to hear and blah, blah, blah. But then again, how? How are we going to do that? The answer is very easy. So let's embed more intelligence into business. This slide here represents a little bit, in terms of diagrams, a little bit what happened between the 20th and the 21st century. So while in the 20th century, it was very important for us to understand what happened, why did it happen, and this we could use analytics to help us as retailers. Descriptive analytics to get us some information, or diagnosis analytics to do some discovery, right? But then, we had a goal. How can we embrace these challenges of complexity, the increase of complexity in terms of the customer and competition. That's when we find out that using predictive and prescriptive analytics could help us turn all of this discovery and information in insights. What will happen? I don't care so much about what happened. I want to know what will happen. These are insights. And even if I know what happened and what will happen, what will help me more is to know how can I make it happen with prescriptive analytics. On this, I can take some decisions. And looking into all of these diagrams, I can assure you that I can act. I can act based on customer centricity policy. I can act based on old and new age analytics, because I'm not saying that we need to get rid of descriptive analytics and we need to get rid of diagnosis analytics, because guys, reporting will always be a part of the business. Segmentations will always be a part of the business, okay? But it's very important for us to combine and to join all of this into the same package for us to act before losing a customer, to maintain new customers, to act on what customer wants or what we want the customer to want, because we do this a lot, and I'm sure you know that. Promoting customer behaviors, right? And to enhance business growth. Because we are doing all of this, it's to keep good customers, because we want customers to spend money on our stores. That's the basics, right? So, now into practice. How are we doing all of this? Which type of algorithms, which type of techniques, on which type of problems are we using this? So we are using a lot of algorithms, and some of them will pass on this slide. We are using regressions, we are using decision trees, we are using time series, we are using logistic regression, support vector machines, naive Bayes modeling, association rules, so you name it. Nowadays, in Somalia, and this is because we have a huge database, of course. If we did not have the customer, the loyalty customer part, as I think all of you are aware of, continental card. All of these give us the power to use this type of algorithms and to use this type of algorithms into business, to enhance the intelligence into business. So some examples. First of all, I will speak to you about product association detection. I'm sure all of you already heard about the recommendation motor of Amazon, right? This recommendation motor is based on, not only on this, because this is a very simple algorithm, the association rule, a priori algorithm is a very simple probabilistic algorithm. But we are using this algorithm to do some kind of in-store promotions decision. What shall we put, which product shall we put near to the other to promote customer behavior? To do some kind of online recommendations, maybe not as advanced as Amazon is doing, right? But to do some kind of online recommendations, and for acquisition campaigns. If you look into the ones that have the loyalty card, if you look into your coupons in the letter that you receive or in your app, you might feel like, these guys don't know me at all. I don't buy this. Why are they sending me these coupons? They don't know what they are doing with their data. Guys, we do know. We are promoting some type of behavior on you because we think, not we, of course, statistics is statistics. Statistics has error, of course. But with a really small margin of error, we know that people equals to you or similar to you are buying this type of product. So this is what we are trying to do. Of course, you will never find out that you are a vegetarian, because we are not allowed legally to know that. So more of this. Customer acquisition models. On this, we are using match techniques and we are using logistic regression. Why we are using this? As you know, in the loyalty card scheme, we have a bunch of partners. We have the partnership with Gulf, we have a partnership with Wells, that is pharmacies, we have a partnership with kids textile, adults textile, and so on and so on and so on. Of course, that we have a 3.5 million customer base. But on all of the brands that we operate, we do not have 3.5. This 3.5 is the number of cardholders that we have. Imagine for Wells stores, we just have 1.2 million customers. It was very important for us to look into our database and trying to find if there are more customers in our database that we can acquire to Wells. Because at some point, people might have the need to, to buy some body care, more premium body care products, and so on and so on. And for Wells, because we in Sun IMC have this team that provide these type of services to all of our partners, they felt that was very important for them, and we helped them to try to find that. Which customers shall they contact to acquire to that business? And this is valid for Wells and for all of the other brands. Another example, redemption rate prediction. So I spoke already about the coupons. We have, and I'm going to speak about this later on, but we have a we are implementing generic algorithms in the optimization problem of coupons distribution. But for that, we need to have an objective function, right? Because optimization doesn't work without objective functions. So, for that objective function, we needed to create some kind of metric. And what we did in one specific case, because we have several objective functions nowadays, it was to predict the redemption rate, the redemption rate for the coupons. So we are distributing the coupons for our customers, trying to maximize the redemption rate. Okay? For this, we are using clustering and logistic regression algorithms. Why combining both? Because it's very important for us to combine coupons that historically turns out to behave more or less the same. And then let's work on some different models per group of type of coupons. Another thing, next best offer or next best action. On this, we are using decision trees. It's very important for us to know what to do at a certain time. We have the redemption rate prediction. Of course, we have affinity models that tells us, okay, this customer will buy this product with this probability in 9 weeks. But if we mix this with a time variable, it's very important for us to know if we are today, and if I want to know which customers shall I target on Monday with a certain product, it's very important for us to have this type of model. Multi-channel scoring. So I told you already about digital, about the more technology and stuff, and we, in our loyalty program, we have several channels to contact customers. We contact customers through SMS, we contact customers through email, we contact customers through statement mailing. Now we have kiosks, and we have the coupons at till. So to manage all of these 5 channels, these are the ones that we have now, right? To manage all of these 5 types of channels, we need to understand the customer, because it's impossible for us to manage to send every promotion on every channel. This is not optimization. So what we deployed, I can tell you last week, was a model that gives us the probability of a customer to redeem a certain type of promotion in a certain type of channel. With this, we can optimize the costs of targeting promotions. Churn prediction. I'm sure all of you have heard about this on telcos, not so much on retail, but we've done this and we developed a model based on logistic regression because it was very important for us to understand which customers will stop by in a certain period of time. Because when we look into our competitors, and when we look to our green competitor, that one that we do not like so much, they have a hard life. And they are going very thoughtfully in terms of targeting, in terms of contacting customers, and we do not want to lose our customers. So it's important for us to understand which type of customers or who are the customers that will abandon us before they do. Let's phone them, let's send them, I don't know, a special promotion, let's try to call them and say, "Dear Mr. Manuel, how are you? Here we are, we have a special service for you." Because it's very important for us to focus not only on promotions, but also on services. This is also customer centricity. Frequency prediction, and here we are using Pareto modeling for targeting marketing and customer retain also to predict the number of purchases that the customer is doing in a time period of 9 weeks or 8 weeks. Sales prediction, so this is the basic, right? Time series modeling. Customer lifetime value, it's important also to understand which are the more valuable customers in the future, not now, right? Because we might have a customer that spends, I don't know, 1,000 euros per month in our stores, but this is this month or in the past. What about the customers that are growing in terms of share of wallet? Speaking of share of wallet, I can't go into too much detail on this project because we are working with a third party on this, but we've developed a model that tells us, that predicts us, the share of wallet of each customer on Continental. So we predict the denominator of this equation, right? How many euros the customer are spending in other retailers. Customer segmentations, then again, the basics. I always say that this is diagnosis, right? To group customers that behave similar. Mailing optimization, this is where we use genetic algorithms. On this, we are using now multiple objective functions. We maximize the redemption rate. We try to minimize the amount of discounts. We maximize the impact on sales. So we are combining 3 different objective functions nowadays. But we need to have caution on certain amount of things. Advanced analytics can be a huge competitive advantage for a retailer. However, we need to focus on data quality. It's very important to have quality on our database. And also, data security. This is mandatory. If we don't look to the security of our data, first, we will be closing doors in 1 year because we will have CNPD after us. And second, because we will have an unsatisfaction on our customers. They need to feel that their data, their personal data, is safe. And also, human intervention is very important on all of these models. It's very important for us to be sure that now and then we look into the algorithms that we put in place, onto the models that we put in place, and just to check if they are working or not. This is because we need to be very careful with the world that we have in our hands. And this world is our customer. And that's it, guys. Thank you.
So, you're still manipulated?
some kind of observation on the coupons and a question. Would you say that you make customers buy what they don't want, but you want them to buy? And how short is your time frame based analysis for the next month? And due to that, would you say that customers would influence what's on your shelves if they bought like water for 3 months in a row? Thank you.
Okay, so I'm not sure if I understood your question, but I'll try to answer, and if not, just please correct me, okay? So when I'm saying that we make customers to buy what we want them to buy, of course we are not applying customers with a gun pointed to their heads, right? We are trying to promote behavior, sending them coupons. Based on those algorithms that I was trying to explain very briefly, we know that customers that behave similar to them and buy those type of products, so let's try to promote these products to the customers that are not buying them, because probably they are buying them on our competitor stores. In terms of time frame, what we do is we look into 12 months. We are looking to a year to work with this type of algorithms, all of this, and more on the probabilistic algorithms. We are working with a 12 months time frame. Okay? In terms of prediction, and because the purchasing cycle is a cycle of 9 weeks, we have this suitable, okay? In some cases, independently on the partner and on the type of business that we are predicting things, because on Wells the purchase cycle is totally different than it is in Continente, okay? On Wells it is 3 months. On ZP is 6 months, okay? But on Continente, the time frame, the life cycle or the purchase cycle of a customer is 9 weeks. So on Continente, the probabilistic models that we are using, we are predicting in a 9 weeks forward. Is this answering your question, or there's something missing? Okay.
Hi, Liliana. Thank you for the presentation. You talked a lot about the algorithms that you guys use, and only a little bit about the data security and quality that you use to run those algorithms. I wonder if you could tell us a little bit about what data channels you guys have to empower those algorithms, its volume, and if you can, from the multiple channels where you acquire data from, you can create a unique profile for the user, gathering attributes from multiple channels, and how you do that.
So your point was trying to understand how we are using data, or how we are collecting data?
Collecting that data, yeah.
Okay, we are collecting data on the front office, right? Because whenever a customer passes their card, we know that that customer did that purchase, okay? We have that in real time, because we do. And this, we have that on real time because we have a database that is our loyalty engine that allows us to give customers discounts on the same time that the customer is in the front of the store. Okay? But to use this type of algorithms, we are not using this real-time database. We are using like I don't like to use the word copy-paste database, but it's more or less like that we call it the analytical database, and we are using that database to implement all of these algorithms.
Okay. Just the second part of the question, are you guys able to enrich that database with information from the user's visit to the website, opening emails, and other type of interactions with the brands that you guys have?
Yes, we do. Every time that a customer identifies himself with a loyalty card, okay, because there's something different between a Continente customer and a Cartão Continente customer. This is two total different things. Because if the customer goes into our stores and that doesn't identify himself with a loyalty card, we are not able to join this. We could. We know how to do it, but we cannot. Legally we cannot, and we cannot do it, okay? But whenever the customer identifies himself with a loyalty card, we have this information.
Thank you.
First over there. We are finally meeting the master puppeteer.
Hi, thank you so much for the nice presentation. I was wondering if you guys use something along the lines of deep networks, some focus on the interpretability of your models, because I think that all the algorithms that you mentioned today so far are non-interpretable, so I was wondering whether that's a future direction maybe?
Do you think that our algorithms are non-interpretable?
Yeah.
Do you?
Yes.
I can assure you that they are. There's one thing, because we are working for, of course, a lot of stakeholders, and I think this probably will answer part of your question. First of all, we are always evolving, okay? Because when I told you that we used random forest for the share of wallet project or model, we did not use random forest until, I don't know, 1 year ago, okay? We are always moving forward and trying to implement and use new algorithms, okay? And this is our plan. But looking backward into all of the algorithms that we used, we have one thing. We work for a lot of stakeholders all along the business, and our plan is not to go there and try to explain to them how the algorithm works. What we do, we run the algorithm. Of course, we have huge amount of time in some projects. There are several projects that are smaller than others. But what we do with the XCOM, when we go to the board, of course, we try to turn around to the models, try to turn around to the results, and just show them the results. First, we test. When I say we test, is actually we are going there to the field and test the models within the customers, on customers' behavior, and then we go to the board and we show them the results. And this is enough, okay? Because for us, we have one thing, we have a lot of business knowledge. When I say business knowledge, I'm speaking about retailing business knowledge. And second of all, we have a team that has the hard skills on techniques to implement this type of algorithms in our database. So I think it's a mix of everything.
Okay, thank you.
Thank you.
So we have time just for one more question. It was over there.
So there's a last question, a bit less on the algorithms and more about the people. And how do you organize these teams to develop the algorithms? Thank you.
Okay. So in terms of people and team organization, we have a team that we call Customer Intelligence and Analytics. And we have a different team that we call Business Analytics. On business analytics, people are more focused on descriptive analytics, reporting, and ad hoc analysis and stuff like that, okay? Not so statisticians, I would say. And on the other hand, on customer intelligence and analytics, we split this team into two. The first one, we call it campaign intelligence. This campaign intelligence is where we set up all of the targeting campaigns, is where we developed and test all of the genetic algorithms that I was telling you about. We implement some text mining algorithms also to try to identify customers and duplicated customers and blah, blah, blah. And we have another team that is our advanced analytics team that goes further into models development, okay? Doing segmentations, doing predictive models, doing some scoring and stuff like that. So this is more or less our organization. Okay.
Yes, sir. Well, thank you, Liliana.
Thank you.